Hi everybody, this is Chris with New England Hi-Fi. Today we'll be working on a customer's Marantz 2275. Brought it in with a channel out, but we're also discovering the problem seems to be it does this. So let's get it open and see what's going on. Okay, so first we're going to see if any of these are control related. I don't think so, but it's worth checking out. Okay, so I am highly suspicious of capacitors at this point, since the noise is not dependent upon the volume control. And it can't seem to turn all the way down, so this could be the volume pot, but I'm not leaning that way. Let's get a closer look at the inside. Okay, so this is the inside of a 2275. This is a later model, which you can tell by some of the component changes, especially this resistor here. It used to be right on the board here. You can sort of see the original outline of it. But they put it over here because it would get very hot and toast these capacitors. Just the tip, it's not a problem with this one, but if you ever come across a Marantz, this power supply board is very similar on all of the 22 series. If you come across one where the relay doesn't click, the first thing to check at the age these things are is this capacitor right here, C809. That's a 220 microfarad, and that is responsible for building the charge that trips the relay. So always look at that one first. If you have a capacitor tester, or it's a pretty inexpensive part, so you can just change it out just in case. I don't think the problem we're having is related to the power supply. I believe it's going to be filter capacitors, or possibly these guys right over here, this guy here. But we'll have to get out our capacitor tester and see what's going on. Okay, here we are in service position. Just about got the bottom off here. The nice thing about these old receivers is that the bottoms tend to come off. So instead of the bottom being part of the chassis with everything screwed to it, they sort of have a frame where the top and the bottom come off, so you can sort of access both sides, which is much nicer than more modern things. So this is our capacitor tester from Peak. We like pretty much everything they make. It's great. We have their transistor tester as well, which works beautifully. So basically what this thing does is reads the ESR, which is basically the resistance of the capacitor. And when a capacitor goes bad, the resistance goes up. Well, it can go bad in two ways. The resistance goes up or the capacity goes up. So you want to look out for both of those things. So first thing we're going to do is test the main filter caps. So with the receiver unplugged, of course, which I won't claim to be perfect about that. You know, accidents do happen. So we just want to clip this somewhere here. Takes a little while. Okay, so this is a very good reading. You want ESR to be as low as possible. Very high voltage ones will have very close to zero, sometimes 0.01, 0.02 when they're good. So that one's all right. These two capacitors share a rail here, so we don't have to move one of these probes. Okay, those are pretty good. Oh, very good, actually. All right, so that's not what our problem is, so let's look a little deeper. All right, so checking the caps in the power supply section. 2 dings is good. That's 447. It's supposed to be 470, but 0.07, that's pretty good for the size of capacitor that is. Let's check its neighbor here. So that's a little high in the ESR. It did ding twice, which usually means it's good, but 465 microfarad, and that is supposed to be, excuse me, 330. So that's not a good capacitor there. All right, let's try this guy. Ooh, okay, so there's a real bad one there too. Those are in the power supply, which doesn't totally match up with the symptom that we're having, but we might as well change those out anyway. So let me get prepared for that. All right, for getting that capacitor out, we like to use my favorite tool, which is the Hacko FR301 desoldering gun. It saves a ton of time. I don't really recommend it if you only have like one thing to work on, but if you do this a lot like we do, it saves huge amounts of time. And that's it. That's the bad one. Let's test it out of circuit and make sure. Okay, so that cap was definitely bad in and out of circuit, so we're going to go ahead and solder the new one in. Kind of big pads on this, so it takes a little bit extra heat. Alright, and we want to clip off this extra little leg here. So it's a good idea to turn the thing back on after sort of each step that you do. Not every component, but whenever you do any work on something, just in case something gets screwed up, you sort of know how to backtrack and figure it out. So I'm going to turn this guy back on. Now I've replaced that cap. See if the problem's there. Make sure it's at least still the same. Okay, well that's a good sign. No noise. It sounded pretty good. Well, it looks like that was the main culprit, that one bad capacitor in the power supply, which I definitely did not call, but that sort of goes to show that your assumptions on things, even if you worked on a million of these, which we have, can sometimes be wrong because they will spite you. But anyway, I think I'm going to replace the other caps in the power supply, and then we'll go ahead and test out the amplifier adjustments and the power supply adjustments. So you want to be careful when you do this. Here they've got glue on the other side holding the cap in, but you want to make sure that you don't pull too hard, even if it looks clean, because you don't want to damage the pads on these. Then you'll be making a lot of extra work for yourself. This one is glued. All right. Now that one looks like it's starting to swell a little bit, even though it measured okay. It's physically not doing so well. This isn't leaking, it's just the glue that was holding it on, but the bottom plate here is pushed out a little bit, so it's probably a good thing we're replacing that. Here's our replacement. This is a 100 volt. We're replacing 63 volt with it, 200 microfarad, or 220 microfarad, excuse me. It probably doesn't need to have 100 volt in there, but this is what we have, and it'll add that little extra capability. Alright, so we get a little bit of extra solder left in the hole, just stopping me from pushing it through. Or maybe it's just... oh, there we go. Never mind. Alright, I like to bend these over so it sort of holds itself in there. Then we boringly off camera get our solder ready. Here we go. And then to clip off the legs, you want to make sure to hold on to these because you don't want little random pieces of metal floating around in your receiver, possibly shorting things out. Alright, that's that one. What else do we have? There's a little 10 volt 220, which we're going to do. Is a little tough to get to. Believe it's this one. Nope. All right. So that one's a little challenging. Without taking this board out, I think I can get it. Got it. All right, that's 220 10 volt. Nippon Chemicon. So these were pretty good caps at the time, but no electrolytic will last forever. All right, we've got a 220 25. I hate these little cardboard stick-on things on these. Very important to note the polarity, positive negative on a capacitor, because it will blow up if you get it wrong. So usually it's marked on the board, sometimes it isn't, but you always want to note when you take the capacitor out. Alright, I apologize for any strange cuts or jumps. We do have a store, so if someone calls or comes in, I might have to stop the video and do that, which is something that just happened, if you noticed. Alright, I'll get this cap back in. And this one was okay, measured okay. This one is responsible for the speaker protection relay. And if this capacitor goes bad, then the speakers just won't work. So while we're in here, it's like a 75-cent part, so not a bad idea to do it. See if I can get these legs clipped off with a show business angle here. Bum, bum, bing. Good idea to get a good hold on the leg. These clippers are supposed to hang on to the bit you cut off, but you know, sometimes they don't. Alright, what else do we have here? These little guys, it's usually okay. So the problem ones have been replaced. The relay seems to work well. Plug it in to make sure the relay clicks still. Alright, so now we replace those problem caps. Let's make sure everything is still working, and hopefully in an improved way. Alright, the pots are nice and quiet. We'll still give those a cleaning anyway, just because this age, just a preventative measure to get some deoxit in there. Alright, but what we'll do now is test the power supply and the idle current and the DC offset. So, be right back. Okay, so on most Marantz, most 22 series, the test points are here, J805 and J804. We want those to be 35 volts, pretty much exactly. And that's adjusted with this little pot right here, which can sometimes get dirty. So if you get sort of erratic results when you're moving that around, you might need a little deoxit in that guy as well. So I'll get our probes hooked up, and then we'll switch to the view of our multimeter. Alright, as you can see, we've got our probes hooked up to those junctions, and we're a little bit short on the voltage that we should have. So we want to get in here very carefully because we've got some voltage going on, and turn it counterclockwise to go up because it's a variable resistor. We want it to resist less. Yep. It doesn't have to be exact the decimal, but I like to get it there. Pots like this can be very touchy. Good. So that's that. Now let's move on to the idle current. Okay, so you'll definitely have to have the amp up on its side when you're doing the idle current. Also something to note, in this model specifically, there's an error in the service manual. So if you're going off the service manual, the one floating out around on the internet that you can get for free, the biggest one normally has that correction in it. But you actually want to test 703, 704, which is this purple wire and yellow wire right here on the amp. And the nice thing about the 2275, unlike the 2270 or the older 22 series, these amps are 100% identical to each other, and they're in, one's not in upside down. On the other ones, the older ones, they'll just flip it over and have it in upside down, which means you get test points on either side. And actually the probes sort of go up in here on the side, which is a real pain. But these amps are really nice because you can actually just pull these Molex plugs out. And there's 4 screws that hold this whole thing in. They'll come right out and you can work on them that way. Huge improvement over the old ones as far as working on them goes. So we'll get our probes hooked up and turn it on and then see what we got. Alright, so we got our probes hooked up and we are getting about 11 millivolts. It's been warmed up for about 10 minutes, which is what you want to do when you're testing this, because voltage will go up over time before the voltage regulator sort of kicks in and keeps it where it's going to be. It wants to be at 10, but I actually like to have these sort of at 12, just to absolutely minimize crossover distortion. So to adjust it, we want to look at this pot right here that will adjust the your idle current. So counterclockwise is down and clockwise is up. So let's have a look. Actually gone down a little bit since I touched that pot because it can be very touchy. Let's give it too much. I like to have it just about there, so that's good. Alright, now let's hook the probes up to the other side and do that. Here we go. We've got our probes hooked up to the same point on the amp. It's exactly the same board, just sort of flipped around 180 degrees. So we turn it on and see what we get. Alright, so that number will go up as the amp warms up, but since I just turned it on, we're going to have to wait a little while before we get a real number. But so far it's looking like it's running a little cold, but we'll wait a few minutes and we'll come back when it's warmed up. Okay, we're still here. Didn't move too much, so it's actually a little colder than it wants to be, and like the other side, we want it to be at about 12 millivolts. For the idle current. It says negative there, but that's just depends on how you have your probes hooked up in this case. So same deal on the other side as this side. This pot here, so the one that's sort of further up and closer to the center, that's the pot we want to use. So let's get that, turning it clockwise to increase the idle current. Alright, so that's good on that one. Alright, now we'll put it back down in its normal zip position and test the DC offset. Alright, so on some receivers they want you to short the amp outs with a resistor before you do this, but on a Marantz you can actually just connect your probes right to the outside with no other changes. You don't want to load on it, so don't leave your speakers hooked up or anything. And you don't want anything playing, so you want it on aux, nothing playing through it, and just sort of at its idle. And this is sort of how we test it. So positive, negative, right into the speaker outputs. Turn it on. After it clicks, all right. Your meter will go a little crazy for a second. And what we want that to be is 0, or as absolutely close to 0 as we can get. Basically, this determines the neutral position of your actual speaker drivers when the thing is on. So as close to 0 as you can get is ideal. Otherwise, you lose a little bit of headroom because your speaker will always, its starting position won't be at your speaker's actual 0. So this one is settling actually pretty good. Getting that amount out of it, 1 millivolt, which is negligible, might be a little difficult, but let's see if we can adjust it. So to adjust, it's this pot that's a little bit lower and a little bit closer to the back of the receiver. So clockwise will make it go up, and we don't want that, so let's get it as close as we can get it. This pot is very touchy, so it might take a little bit of playing to get it just right. So we're going to the negative here. Alright, so there we go. That side is good to go. Now we'll switch to the other side and do that side. Okay, now this is the left side, hooked up the same way. Let's see what we've got. Alright, nice. So anyway, again, on this side, they're flipped around because the amp is 180 degrees flipped from the other side. So like that on that side, like this on this side. So we want the one that's sort of lower down in there. We'll adjust that out of there. And again, we want it at 0 or as close as we can possibly get it with the 40-year-old pots that are in here. Alright, so this one is good. Actually, a side note, these pots are an improvement from the ones that are in some of these. Some of them have sort of a tall, knurled top on them. Those ones are sort of all open and they're really susceptible to getting dirty. These ones we find are actually pretty good. Usually don't need to be cleaned. But if they ever do, you can sort of get your deoxit down through here, a little bit in these little dots right here, and then just sort of work it around to get rid of it. But DC offset is good, idle current is good, power supply is good. So let's hook it back up and see what she sounds like. Alright, all hooked back up. Let's turn it back on. Get some of that smooth jazz. Alright, sounds like an old Marantz. A little bit on the bright side, but very nice. Alright, so now to the cleaning. Alright, so the first thing we want to do is get all the knobs off. Now these are just knurled pots, and they all pull off. You want to be careful because sometimes the glue that holds the aluminum onto the plastic inside will come off of the plastic, and then you'll have to glue them. There's not really much you can do to avoid that, but just something that might happen to you. Alright, that was easy. Get ourselves a little cup. And don't forget the balance knob. These will all come off around, the plate will come off around these, so you don't have to take all these little guys off. And I would highly recommend not doing so because the posts for these are plastic and you can break them. Alright, so the next thing we want to do is take these little bolts out. They're not quite decorative. I just use a little crescent wrench. And you don't want to push too hard because you don't want to scratch around them like somebody's already done here. Just loosen them. They don't put any lacquer or Loctite on these, so they will come out by hand once you sort of break them free. Just again, be careful with this wrench. You don't want to scratch the faceplate. It's already been scratched on this one, but it's always good practice not to add any damage to things, even if they've already got a little bit. Now it's not quite ready to come off once you take this out, because there's one more thing holding it in, which is this little collet here. And yeah, normally you can just do it by hand. If you can't, if you can put a little screwdriver like this in here, be very careful to sort of break it free. This one can be done by hand, so no problem there. Alright, once that's out, faceplate will come off. It's very easy to clean this. I would suggest doing it in a sink. Be careful of the felt, and these little guys that are glued in can pop off sometimes, so you want to be very gentle around those areas. But all of these fingerprints and stuff that's embedded in here, some dish soap and hot water works really well on these. Sometimes you might have to soak them a little bit, but again, be careful of the felt. Alright, so at this point we're not quite ready to get to our pots to clean them, because you definitely don't do it from this side, you have to do it from the back. So we'll put it back into service position and I'll show you how to get that out. Alright, so this is the board that all the pots are on, with the exception of the volume pot, which is here. Let me show you that. Here. So to get this board out, a couple of things you have to do. So these brackets, we'll have to take them out. Sometimes you can get it out just by loosening them, but I would recommend taking them all the way out so you don't have to monkey with it too much. And then this plug here will unplug. Normally there's a little plastic tab here that holds it down. This one looks like it's been broken off at some point. But the first thing to do would definitely be to unplug it. And you want to make sure that, of course, the receiver is not plugged in when you do this. So those are going to come out. Very good idea to use a magnetized screwdriver, because again, you don't want to lose anything metal down inside of a receiver. Brackets out. Brackets out. You can just sort of work this thing out, and it will catch on the pots in the front and be very irritating, but you can get it. Maybe. Okay. Let's take this riser out. Should give us enough room to get this thing out of here. Aha. Alright, so we'll get this down and we'll check out hosing it down with the aux. This is the EQ board outside of the amp. We're going to want to check these capacitors here while we have a chance to get to them. Then we'll clean the pots out. Okay. All right, both of those ones are not great. Let's see about this one. Gesundheit, Adam. Also not great. And this last one here. Very close to being shorted. Not great. Alright, so I'm going to dig around and find some replacements for those, and we'll be right back. Alright, so we have all the capacitors to recap this board, which it definitely needs. I won't make you watch every single one of these, but we'll start taking them out. One thing to watch out for on these boards, these two caps here are bipolar caps, so you will want to replace those with bipolar capacitors, or else bad things will happen. But we have some right here, just the right value, because it's pretty common in EQs. But we'll get back to it. Okay, all our capacitors are in place. We just have to solder them in. This is kind of an old board, so we're going to put a little flux on there first. Very little. A little tiny bit goes a long way. Just a tiny bit. Most of these pads are pretty clean, so it's not really that big of a deal, but can't hurt. Well, these ones are these pads are sort of bridged together with solder, so we'll just put a little extra on there, just like they did. Same with these guys here. These two pads are very close together, so you want to make sure that you don't accidentally short them together. Sometimes flux can make it easier to do that, so you want to be careful. Alright, we'll get clipping those off, and then we'll actually clean those pots. You don't have to watch me do every single one of these, but you get the idea. Okay, that's the board recapped. You can see that this one is much smaller than this one, which was the original one, which was sort of stuck over there like that just because it would stick up too much to fit in there, but modern stuff tends to be a lot smaller. That's actually a 50 volt instead of a 35 volt, so one benefit of modern stuff is that it's much more compact and easier to fit in. So to clean these pots, you want to get your deoxit under there, so it's still, even with it out, kind of sucks. So you really just have to sort of spray it in and let gravity get it down in there. you want to your deoxit, if you have an adjustable can. These are the old cans, which are you can still find, which actually work well, and the new ones really suck. But you want to get it sort of drizzled down inside. And then just turn them a lot. These ones weren't really noisy anyway, so we don't have to go too crazy. Then this selector switch, which is the bypass switch for the tone controls. There are these little pads with contacts, and we just want to clean each one of those. So we just get some deoxit basically anywhere there's metal on metal contact. All right, now we can put this back in. Okay, so you're going to clear the threads through the front, and also just make sure you're not pinching any wires when it goes in. All right. All right, so these are all bolted back in, and we'll go around to the other side and put the brackets back in. This one's a little bit tricky. Okay, so don't put the screw all the way in because you've got to get the board sandwiched in this little black thing here. Alright, so most of the way in, but not all the way in. Again, magnetized screwdrivers are the best here. So get it in, sort of slide it into place, make sure it's tight. So we want to do our best to not put any stress on the solder joints for the pots. Alright, so I'm now going to clean the faceplate, which I don't know if I need to record because it's pretty much just like cleaning a dish. But we'll see the end result in a moment. Okay, the faceplate is all clean, but before we put it back on, we want to make sure to clean behind, especially the visible areas, like the radio dial here and this little thing that tend to build up dust over time because it's not sealed on the top here. I also want to make sure to clean these buttons because you won't really be able to get to them afterwards. I really like to use just a little bit of Windex on a microfiber, as Windex will not leave streaks and it evaporates really quickly, so it won't leave anything wet, which we don't want to leave moisture in there when we put it back together. And these will usually clean up pretty easily unless someone was a real heavy smoker or something. You really get to scrub them, but not the case in this one. But you never know. Stuff from the 70s, different times. Sometimes we're cleaning paint out of these things, little bugs, lots of dust bunnies. And sometimes just scrape it off, tar. But this is pretty good. Also a little post for the balance control, because a little of that will be visible. And the top side of the tuning dial. And also we got a little bit of something on here. Take that off. That's pretty good. All right. Faceplate's ready to go back on. Like so. All right, we're looking much better, much cleaner. And now I have to clean the knobs. And I'll put this guy back together. All right, so when we put these knobs back on, easiest thing to do, I find, is just to put the pot all the way down and line up the pointer with the lowest setting. So that you can, I don't know if you can see, but this one doesn't quite line up, so this is not the correct knob. They didn't include the splines in the right spot, or they did for a different control. Let's see how this one goes. All right, that's the one for that. You're just going to be careful when you put them back on. If you want them to line up right, you might have to try a couple. Nope. Let's try that first one. There we go. These ones are pretty easy because these are not spline pots, these are keyed. We just sort of clean them up as we go. See how it is. Done.